Video for Module 5, composition of functions. Since this is, like I mentioned in my first video, a little bit of a reach back from a long time ago for me, since I don't teach this, I'm going to do my best to kind of attack this problem here. So if I were teaching this, now that I have a better idea of how to do it with using the inverse operations rather than just switching out the x and y, I would go ahead and start finding the operations that are being done to these the terms in and to the x specifically in this function. So v of x equals 2x cubed minus 7. So the first thing being done to this x, the first operation being performed to it, is that it's being raised to the power of 3. So this is the way I'm going to kind of draw a little caret to the third. This is a little weird the way it does it, but caret to the third. So after that's done there, this x to the third power is multiplied by 2. We do times 2. That times a little bigger, or multiplication symbol. And then it is subtracted, so 7 is subtracted from that number then. So to find the inverse operations of each of these, we have to go backward kind of. So it's going to 1, 2, 3, the ones that are being done. I'm actually going to go backward, starting at the bottom. So the inverse operation for subtraction would be addition, so I'd be adding 7 first. Sorry, my cat's knocking over everything. And then I will be dividing by 2. And then I will find the cubic root to finish it off. So I'm actually going to go back up that way. So now let's create the new function. I'll do it in a different color here. So my z of x is the inverse that I'm creating now. So the inverse is when composed within each other. If I did v of z of x, it should come out to just x, and vice versa if I did z of v of x. So I'm going to do, the first thing that I'll have to be done is the x plus 7, since 7 is the one we're starting with at the bottom. Then what I'm going to do is I'm going to do the little division there, so divided by 2. And then we have the cube root, so I'm going to take this whole thing and do a cube root here. Okay. So now I found my inverse, but I need to test it out. So I'm actually going to do v of z, and I know there's a few different ways to write this, of x. And I did address this problem in the original video that I made, but I'm going a little more in depth here. So I'm going to actually have to put, compose this second function within the first function, 2, and then for my x, I am substituting 3, I'll just write this out and then I'll go over what it is. So basically what I have here is if I go back to this original one here, 2 times x cubed, so my x now, my new x, when I'm composing these functions, is all of this here in my z of x. So I'm plugging all that in, then I put it to the third power since that's in the original function, and then subtract the 7 since that's in the original function also. So it kind of looked like a lot the first time I looked at this problem. The first thing I really did was I noticed that it was, I have to do my my exponent here, but this is to the third power of this cube root. So it's going to come out to, I'll just do my equal here, 2 times the quantity of x plus 7 divided by 2 to the, oh, sorry, not, that one's not to the 3rd power anymore. Minus 7. That'll be my first step here. Next, I'll be multiplying by 2 here. So since there's a 2 on the top, 2 on the bottom, makes a 1 pair. So 2 divided by 2 is 1. I'm just going to have x plus 7. And to make better use of this associative property of addition, I'm going to say this plus negative 7. So now that I can do the associative property, I'll have x plus 7 plus negative 7. That makes a 0 pair, the plus 7 and the negative 7. So I'm just going to have x as my result here. Therefore, I'm showing that these two functions are inverses, and I'm trying to really use the properties of the inverse property, identity properties, and 1 and 0 pairs that we've addressed in prior modules. All right.